Hello, everyone. Thank you so much for joining us for this talk, Why Rust. Rust is an emerging programming language that's actually got a quite bit of usage from Mozilla and other people. I hear a lot of people using Rust for their low-level applications. And we're very fortunate to have with us one of the core maintainers of Rust and the founder of the Rust Foundation as well, Ashley Williams, to tell us why to use Rust.
All right. Can everybody see my screen?
Yes.
All right, fantastic. Well, hey folks, I'm really excited to be here talking about one of my favorite topics, Rust. When the organizers reached out to me, they shared that they would really love to see a talk about motivating folks to use Rust or why they might use Rust. So that is going to be my topic for today. But just quickly, a little bit about me. I know that Mark had already shared that I'm a member of the Rust core team, and I also was the founder and initial executive director of the Rust Foundation. So if you do happen to already be using Rust at your company, I would strongly encourage you to get involved in the foundation. This is not a talk about open source sustainability, but I probably could give like 5 on that. And so supporting Rust would be fantastic. So my background is somewhat varied. And one of the things that I do like to share is I have not just been a Rust developer in my life. I actually started back in first grade as a logo programmer. And then did some HyperCard, but I started my professional career in Ruby and actually spent a fair amount of time in the Node.js JavaScript world. I transitioned to Rust right around the time WebAssembly was becoming popular, and we'll dig a little bit into what that is. But I've done a lot of things in my life, but one of the things that I kind of see as the thread amongst all of the things that I've worked on is the idea of empowerment. And that is something that is very, very central to the idea of the Rust programming language in general. So, Google Slides, there we go. All right, so if you were to visit rustlang.org, the website describes Rust as a language empowering everyone to build reliable and efficient software. And you'll see that I've highlighted that word empowering, and that's an incredibly important topic. And I'd like you to keep it in mind throughout the rest of the talk. So my goal today will be to give you a general overview of Rust as a programming language, what I like to call batteries included that come in Rust, because Rust is significantly more than a programming language, and then talk a little bit about why people choose Rust for their products and projects, and potentially why you might choose to do so. My goal is to hopefully only take half of our time here today with the presentation, because ultimately the question of why you should use Rust is incredibly contextual. And so I'm hoping to have a lot of questions from everybody. So if you could post your questions in the chat, that would be absolutely fantastic. And don't be afraid to get spicy. I'm really excited to be able to hear what folks are thinking these days. All right. So let's dive into kind of what Rust is and what people use it for. So the first thing to say is you've probably heard of Rust. Rust is not a quiet programming language by any means. And if you happen to be online on Twitter, there's a whole bunch of folks who talk about Rust. And for the 6th year, Rust was announced as the most loved programming language in the Stack Overflow developer survey. Now, there's lots of criticisms of the survey, and I think that's very fair, but I think Rust is definitely one of those languages that's kind of notoriously loved by developers. But the discerning eye would note that despite the fact that this is the 6th year that Rust is the most loved programming language, if you were to look at popularity of the language and how frequently it is used, it hovers around the 15th position, which is significantly lower than its position in the loved. And so I think it's an extremely fair question to ask, why is the adoration of Rust not aligned with the usage of Rust? And how do we see that growth of Rust usage happening? So a lot of that is what we will talk about today. All right, so I would be remiss if I also didn't say the Rust Foundation was formed last year. And I think with that, we've seen a lot more public discussion of folks using Rust. And so this is just a screen cap of the members of the Rust Foundation. There are many, many more companies that use Rust today. But it's worth noting that the ones that not only use Rust, but also help publicly fund the Rust Foundation are very varied in what they do. So some of the ones that I love to point out here that are a little bit smaller that are very interesting, you'll see Toyota is there, ARM is there, calling out some of the embedded and IoT work. You also have a lot of network services companies. So you have things like Dropbox. You also have Web3 and encryption like Zama. And so there's a real diversity in what people are using Rust for. And Rust was only 1.0 in 2015. And so as the years go on, we've definitely seen usage of Rust dramatically increase. So a lot of people ask, hey, what can you use Rust for? And in the early days, we used to advertise Rust as a systems programming language, which I think did a real disservice to the kind of collective imagination of what people could do with Rust. When you talk about systems languages, often people only think of, firmware or operating systems. But today we see Rust used all over the place. So I think one of my favorite usages of Rust that I've seen are CLI tools. But WebAssembly has allowed Rust to move into the containers game, which I think is very interesting. But we also see lots of games companies and as well as network services companies and IoT companies using Rust. So when we think about Rust and its usage, it's not really constrained by what you can use it for. And every day I'm hearing that folks are using Rust for something new and fascinating. So when we talk about programming languages and we talk about tools, inevitably developers love false dichotomies. And we often see Rust compared to Go. We've seen Rust compared to JavaScript. And when originally Rust was developed, it was developed to replace C++ in a browser. I have a lot of criticisms of these, and I hope folks ask questions about these comparisons, but ultimately Rust is not attempting to take over any one of these languages' spaces. And in fact, Rust is often a complementary language to many of these tools. So if you have pigeonholed Rust as a competitor to only one of these, consider broadening your perspective of where and how you can use Rust. So these are some categories or attributes of the Rust programming language that many people are familiar with. So Rust is a compiled language. I also like to share that it is a cross-platform language. Cross-compiling Rust is incredibly easy for certain values of easy, of course. I did notice that there was a panel on types earlier, and so I won't dive too into this, but Rust is also a statically and strongly typed language. And these three attributes of Rust allow Rust programs to be small, portable, and fast. But these characteristics of Rust, which I think are really fantastic, are only going to really move the needle for you depending on the types of languages you're coming from before. And so if you'd like to dive deeper into these, please ask questions on this, but I probably won't linger too much longer on these. Instead, I'm going to focus on one of the most classic descriptors of Rust, which is its memory safety. So there was at one point in time a moment when we were only advertising Rust as memory safe. And similar to advertising it just as a systems programming language, I think this really limited people's imagination about what Rust could be. But it is really quite amazing what Rust is able to do with memory safety, and I would be remiss not to talk about it. One of the things that I will say, though, is that for the entire swath of folks who are using garbage collection today, like languages that are garbage collected, you already are using a very memory safe language. And so memory safety is really considered something that is like a benefit of Rust for folks who are coming from not garbage collected languages. But we can go into that in just a little bit. But so memory safety largely means that the set of bugs that come from using memory incorrectly or unpredictably is eliminated. So when Rust was originally written, it was conceived of first as a personal project and then transferred to a research project at Mozilla. And Mozilla needed a language with memory safety because it was attempting to write parallelism into its Stylo engine. And doing that in C++ was incredibly difficult. They were getting a ridiculous amount of security issues, and it was also just kind of becoming functionally impossible to do without databases. And so this is an article by Diane Hosfeld, who is a security engineer on Mozilla, on the Mozilla browser. And this quote itself, I think, is really interesting. But in her blog post, she writes, over the course of its lifetime, there have been 69 security bugs in Firefox's style component. If we'd had a time machine and could have written this component in Rust from the start, 51, which is almost 75% of these bugs would not have been possible. So when we think about languages that say you were to write a browser in that have incredible performance, they're often said to give you a lot of low-level power. And this cartoon here indicates that with that low-level power, you are able to achieve an incredible amount of performance. But unfortunately, a lot of that performance comes from your ability to kind of take shortcuts with memory safety. And what Rust is attempting to do is to say, have your cake and eat it too. You can have low-level ability to achieve an incredible performance in your application, but we're not going to let that application cut corners in memory safety. An ancient Rust proverb is the safest program is the program that does not compile. And so instead of memory safety being something that your programmers need to review code for to find errors with, it's considered a check at compile time, which is to say, if you have a program with memory safety issues, that program will not compile. And so this simply eliminates a large class of security bugs that many applications have. I saw earlier today, I think it was on something else, but I don't need to fearmonger on security issues in the wild. There's an immense amount of them. And while for a while we believed that having wizards that could review code and just know like when a security or safety issue is happening, one of the things that really drives Rust's empowerment is the idea that you do not need to be a wizard to be able to write performant memory safety code. And that comes from the fact that that is built into the compiler. So let's talk about some of the concepts that Rust introduces to achieve this memory safety. So memory safety is by far what I would call the Rust strangeness budget. We spent basically all of our ability to be weird and strange on this idea that we want to build memory safety into the compiler. And so when you hear that Rust is difficult to learn, it often is related to these concepts. Now, one thing that I will share is that these concepts are built in, and it is true in the course of writing any application, you're going to encounter these concepts, but encountering them is not something that necessarily needs to slow you down. And often it is not the first thing you encounter. There's plenty of Rust that you can write where you don't even recognize that these things are happening. And so while when folks talk about Rust, they love talking about ownership and lifetimes and memory safety, I do want to make sure that it's clear that when you're writing Rust, that's not necessarily something that's directly in your face. So you're able to have some time to learn it. But all right, let's dive into what ownership and borrowing are. So ownership, and I've written these things out, these are incredibly complicated concepts. And so these are going to be some kind of more generic descriptions of them. We can dive much deeper. Each of these could be their own series of talks about how this works. But ultimately, the idea of ownership is that Rust will keep track of who or like what context owns each value, and will only let that value be used once and it will refuse to use it again. And then borrowing is the idea that Rust keeps track of references, and this is how it uses lifetimes. And these are keeping track of references both to or into a value. And you might be like, what do you mean by into a value? That means something like a struct, where it's a value that holds other values or potentially other references to values. So Rust will keep track of those, and it won't let you move a value if there is a reference to it. It'll also ensure that there's only one mutable reference at any given time, and that there are no immutable references existing at that same time. So that's a lot of words, but one of the ways that I really like to describe this, and this originally comes from a presentation by Nico Matsakis, who was a former core team member and is currently the language team lead, where it's the idea that if I lend you my book and I intend to get it back and read it later, you shouldn't be allowed to burn it. Now, when I say it like this, it sounds almost obvious, right? But encoding this type of like value into a programming language is actually relatively hard. And when we're using values in other programming languages, we often just kind of trust that our friend isn't going to take our beloved book and burn it with our anticipation of being able to get it back and read it. So in a way, this is saying, hey, you don't need to trust your friend not to burn your book. We're going to ensure that your friend won't. We won't let you lend that book to your friend until we can be sure that they won't burn it. And so that's the general background on how memory safety works. Additionally, I'd like to point out, it often gets a lot less attention, but in addition to memory safety, Rust also has null pointer and data race safety also. I like to say here in like the meme style, like as a treat. But ultimately what Rust is trying to do is there's a very large number of ways your program can go wrong. It tries to take some of the ones that it can know is going wrong at compile time and eliminate those from being something that can be discovered at runtime. And this theme of let's do the work up front, I think is one that we'll see a lot as I discuss Rust. All right. So if you've ever used Rust or have been trying it out, I like to point out this was a kind of hilarious tweet that went around in January where it was like, quote tweet this with a pun about your job Arnold Schwarzenegger would make if he killed you in a movie. So if you're writing Rust, you'd likely hear this: borrowed value does not live long enough. And inevitably, I think this is one of the hardest things to start wrapping your mind around when you're writing Rust. But as I said, it's not something that comes up like immediately, like when you're just starting it. And it's something that there's a lot of really great resources to help you figure out. But beyond memory safety, and speaking of error messages, Rust comes with a whole bunch of other real niceties. And I often think that while memory safety is one of those fantastic benefits of Rust, almost everything else that Rust comes with, I feel like is perhaps more important. So Rust has absolutely fantastic compiler error messages. These are just a couple. They're very inspired by the Elm error messages, if you're familiar with them at all, but they will give you the portion of your code that has the error message. They will give you suggestions, and they'll give you the context of that. And they'll also, within the CLI itself, be able to give you extra information about the error message. And I think this is an incredibly important element of Rust. While it's checking your code to make sure that things are correct, it also wants to help you make sure that they are correct. And it doesn't just leave you kind of like in a lurch saying that your code isn't, where a lot of programs, I think, that have this type of strict correctness don't have the empathy to bring you along the journey to get it fixed. And I have to credit, whenever I'm talking about error messages in the Rust compiler, Esteban Kuber, who really just says it best here when he discusses the Rust compiler, that we spent decades trying to invent a sufficiently smart compiler. For folks who have ever read compiler discourse, the idea of a sufficiently smart compiler is pretty common. But in Rust, Esteban says, when we should have been inventing a sufficiently empathetic one. So there's a real focus on developer experience, understanding developers' intentions, and being able to guide them towards the right implementation of what they are intending to write. And this is really, I think, at the heart of why developers really enjoy using Rust. So Rust was always kind of positioned as a systems programming language, and it entered this area of systems programming where there was this kind of vibe that if it is really hard and complicated, that probably means it's good. And I think this is an incredibly harmful perspective. And Rust takes the perspective that, of course, no, like in order to be something that is fast, safe, correct, it does not need to be really hard and complicated. But people who felt this way, that something really hard and complicated probably was good, aren't just cruel or potentially gatekeepers. They're coming from the perspective that for much of programming language's history, we started adding layers and layers of abstractions to things, and those abstractions made things easier, but they came at a cost. And particularly because of the strength of Rust's compiler and the fact that Rust is a compiled language, we're able to add layers of abstractions that make the developer experience delightful while doing so at no cost to the end user of the compiled program. So it's always kind of, confusing to see this idea of zero cost and there's no such thing as free, but because of the Rust compiler, we're able to give the abstractions that you would expect that build the developer experience that you see in a lot of dynamic languages. But we're able to compile those away so that not only can the developer have a great experience, but so can the end user. All right. So a lot of this comes down to this concept of developer experience, when a decade ago, we weren't really talking about developer experience, but I feel these days we've heard it a lot. One of my favorite ways to describe developer experience is this cartoon from the New Yorker, where you see two women sitting on a bench and they say, "I like this painting because it has a bench." And people will laugh because in general, there's this idea that paintings have some type of objective value because of their artistic quality. And I think people feel this way about developer tools as well. But what Rust says is hey, the painting is better because it has a bench, and benches are fantastic. And I would be remiss to not talk about the portions of Rust that aren't the Rust language, Rust benches. So just really quickly, Rust comes with a tool for managing versions of Rust and release channels of Rust called RustUp. If you've ever had to teach somebody how to get started with Node or Ruby, you would probably appreciate that this is something that's official and produced by the Rust organization itself. There's an innumerable number of developers that we lose simply to environment setup. And so RustUp really just makes that incredibly simple. There are, of course, a million other ways to install Rust, but this is by far really the best one. Then there is Cargo. So Cargo is kind of the everything tool in Rust. It is the tool that you use to build and compile Rust. It's also the tool that will install and manage your dependencies. It has built-in testing. It has quite a few things in it. And every day I feel like there's new things added to Cargo that are just absolutely fantastic. And so it's just an incredible tool. The other side of Cargo is Crates.io. So, I mean, when we originally were writing Cargo and Crates.io, the author of one of the authors of Cargo said that he never wanted to see people write a make file again. And I think that he's achieved that. Crates.io is where you can both download, binary applications such as CLI tools, but also any number of packages. And the ecosystem on Crates.io has really dramatically grown. RustDoc. We feel really strongly about developer experience, and documentation is a part of that. These pages that you see here are generated by RustDoc. So it's a little recursion. RustDoc's documentation is via RustDoc. But you can put documentation comments in your code and then generate this. These are all hosted on docs.rs. So every crate on Crates.io can automatically get self-hosted generated docs like this, which makes navigating and using the ecosystem incredible compared to if you've used anything, say NPM, where maybe it has documentation, maybe it does not. But these really, the fact that these tools are built into the ecosystem really gives the affordance for people to write that documentation. And there's also a lint where you can actually deny compilation of your program if documentation has not been written for any public functions or structs, which is really fantastic. Then there's Clippy. Clippy is one of my favorites. I get a lot of questions from folks about whether or not they're writing idiomatic Rust. And so Clippy, similar to the Microsoft, hey, looks like you're writing a document, will help you with all sorts of kind of code style work and help kind of nudge you towards more idiomatic Rust. There's all different levels of this, but there's a default one, and it's honestly a great tool in starting to learn how to write idiomatic Rust. And then finally, I can't say enough about this. For a very long time in the Rust surveys, we saw that folks really wanted better IDE support. So Rust Analyzer is the fantastic language server protocol implementation for Rust. And it really does a fantastic IDE experience. If you like your autocomplete, this is for you. This is just a GIF of just one of the things, but there's a really fantastically large amount of things that Rust Analyzer is able to do for you. So to the final question here, should you rewrite it in Rust? Probably if you've ever posted on Hacker News or Reddit, you've had somebody swoop in and tell you that you should. Those people who swoop in, by the way, had once branded themselves as the Rust Evangelism Strike Force. And while I appreciate the enthusiasm, I can't start with how frustrated leadership in Rust often was, because Rust wants to be good of its own accord, but forcing folks to rewrite things in Rust or like over eagerly encouraging them is not the type of vibe or culture that we're looking for. So we have seen a lot of growth in Rust. This is from the Rust 2021 community survey. This was the very first time that people saying yes, they used Rust at their work went above 50%. You can see that it's not much over 50%. It's the dark blue, green, and orange here on this pie chart. But we are starting to see more people being able to use Rust at their job, which is really fantastic. And that's given these numbers something of a little bit more context and a little bit more folks participating. So in general, people reporting on the community survey about their usage of Rust at work was overwhelmingly positive. The ones that I think are really important to note, like overall adopting Rust has slowed down our team. A lot of folks disagreed with that, but it is something that we hear quite a bit with folks, and we'll talk a little bit about that in a second. But you'll see on this second one, adopting Rust has been challenging is something that a lot of folks agree with. And what's interesting is oftentimes the challenge of using Rust is attributed to its ability to be learned. But for the rest of the talk, I'm going to kind of propose my hypothesis that I actually don't think that's the case. So whenever we talk about picking tools, you'll often hear the developer community say, well, you should pick the right tool for the job. And hopefully you can already hear in my tone that I'm a little skeptical of this. So first you have the question of what does right mean and kind of what does tool mean and what does job mean? And if you're going, okay, this person was probably a philosophy major. Yes, words have meanings, but do they? Like when I think about it, programming is really the art of deciding what the right tool for the job is. And in that way, saying you should pick the right tool for the job is really not helpful at all. In fact, the work to be done is figuring that out. So what I'd like to leave you with is something that has really guided Rust development, and I think should also guide you in your journey of deciding on a technology. So Rust really genuinely believes that programming is about people. The first commit to the Rust programming language was a code of conduct. We take our community incredibly seriously. And that's not just a superficial thing, it is baked into the language itself. Hopefully my discussion of all of the developer experience benefits of Rust help indicate that we really center the developer when we think about the technology. And so when you think about it, one of the biggest things I've seen when folks want to choose Rust is I like to ask them the question, can you afford to solve your problems up front? How much can you afford to build yourself? And how open is your team to change? And I'll usually draw something like this on a napkin when I'm talking to people about this. So a lot of what Rust does and a lot of Rust safety guarantees come from the fact that it makes you solve these problems up front. These things happen at compile time, right? The safest program is one that does not compile. So the chances of you having a workable prototype with 800 memory safety issues is 0. And so if you don't have the capacity to be able to invest up front, Rust is likely not a great choice for you. Even if you do have that capacity, I think it's really important to note that Rust kind of changes the time frame that you think about your applications and your software in. You're going to have to put a lot more upfront before you get that kind of initial dopamine hit. And while improvements in error messaging and all of that like help bring that initial investment down, just being able to recognize and make space for the fact that investing in Rust is going to mean that you're going to be putting up a lot up front is really, really important. And it's the biggest stumbling block I see with people adopting Rust. When I worked at NPM and convinced us to rewrite some stuff in Rust, one of the compliments that our CTO gave it at the time was that Rust was very boring. And that's because we had been using a series of node microservices and we're dealing with incredible like memory leak issues. But with Rust, you kind of, once you got it going and you were able to deploy it, you had an otherwise pretty simple time. Rust does not prevent logic issues. So I should be clear about that. It's not a non-zero, it won't solve everything for you. But you really do need to be prepared to solve things up front. So the other thing I'd like to point out when thinking about rewriting something in Rust is, again, the people on your team. We often talk about the right tool for the job, but I also like to say, like, what's the right tool for your team? Because when you think about right tool for the job, it implies that there's people involved, but it doesn't actually directly talk about them. So asking yourself questions such as like, how quickly do you need to hire? How senior do you need your hires to be? In our Rust survey, you can see here, there's almost 40% of folks saying that they're able to productively write Rust. But you'll also see that more than half of folks either say they can't do it, they can write simple programs, but not complex ones, or they can write useful production-ready code, but it's a struggle. There's significantly more people in that area. Now, as time passes and Rust continues to grow, that will change, but it's important to recognize whether or not you're able to hire someone who's still on their journey to becoming a Rust developer, because there's significantly more of those out in the community now than, say, Rust experts. I would also share that in my experience, the Rust community tends to skew younger. So even if they're a Rust expert, they may not be someone who's very like senior in their career. And so it's important to pay attention to like what types of people will be successful on your team and making sure that there's a pool of those who are able to write Rust. All right. And then finally, one of the things that I really like to mention is, do you have a remote or a distributed team? And can you hire outside of the US? I think one of the things that I've really enjoyed about the Rust community is, while it does have the largest representation in the United States, that representation is 24%, which is significantly less than half. When we did our first Rust team all hands, we actually had it in Berlin, Germany, because based on the weighted mapping of the entire community, that was kind of the center of gravity for the Rust community. And so there's a lot of Rust folks who exist outside of the US. And I think if I were to build a new Rust product today, I think ensuring that my team was distributed and remote and could hire outside of the US would be a really important aspect of that. I think there's also other benefits beyond the fact that there's Rust talent in places outside of the US to have a remote or distributed team. But I think it's important to recognize that Rust is definitely a global language. So this is a little bit of a summary of if you're making a decision about whether or not you want to write something in Rust around these pros and cons. Now, the thing here is like whether something is a pro or a con really depends on what you are trying to do. Like here under cons, I've listed high upfront development investment. But if you have the space and time to do that, that's not necessarily a con. But I do get this question a lot, and this is kind of how I think about it. Now, what you might notice here is that the list of cons is significantly shorter than the list of pros. And a lot of this has to do with the fact that I've seen a lot of companies just organized in a way where these cons are really not negotiable. So this again really comes down to, are you able to make the time to invest in something up front? Or do you really need to be kind of like, I hilariously often refer to like just in time or jitting something. And there's just a lot of companies that don't give themselves this type of margin. And as a result, investing in Rust is very difficult for those companies. But to end this all, what I'd like to say is ultimately programming is about people. This value has guided Rust development, and I think it's guided us towards an incredible piece of technology that has a community that's made up of extremely smart and empathetic people, which is a composition I think any company should attempt to achieve. And when we talk about our developer tools, I think we're really bad about talking about the tools that we really like. And I think that's because it's not the tools we like, it's what they let us become. So this is a concept from Kathy Sierra, where she talks about product companies. And so she says, in general, like you have this Mario and then you have a fire flower. If you're not familiar with video games, a fire flower is this kind of tool in the Mario universe that Mario is able to pick up. And so oftentimes product companies think that what they build is fire flowers. But what Kathy does in her idea here is she kind of inverts that and says, your business is not the product you make, but your business is what you allow your customers to become when they use your tool. And this was incredibly important for Rust. Hilariously, we call it the fire flower moment in Rust. And this is when we started changing how we advertise Rust from a memory safety language to this idea of empowerment. If you're interested in reading this, I think this is one of the most interesting cultural artifacts of Rust. You can go to this URL here or just Google fire flowers Rust. But Rust is really more about the types of things that you can build and become when you use it. So I will leave you with this. Rust has become successful because it has prioritized people over technology. And that's not to say we haven't built some absolutely fantastic technology, but I think in prioritizing people, that's how we've been able to do that. And so as you think about choosing Rust for your product, I would say your decision to use Rust will likely be determined based on your prioritization of your own people. So definitely start there and then consider the technology second. All right. And with that, let's do questions. Thanks.
Oh, thank you so much. We have about 23 minutes left for questions. So
perfect.
I see one already. Niraj asks, you mentioned systems programming. How supportive is Rust as a web application language?
Yeah, absolutely. So if you had asked me a couple of years ago, I would have said that it was probably not a great choice. People have been writing network services in Rust for a very long time, but one of the things that lagged was the async story in Rust. And if you've been paying attention at all to the Rust blog or the Rust language team, over the course of the last 2 years, the async story in Rust has just dramatically matured. And so I would strongly recommend that you use Rust for your web services. When I convinced NPM to do it, I actually convinced them to rewrite a web service, and before even the async story was possible. But I mean, when you see a lot of the FANG companies listed on Rust Foundation's website, many of them are using it for network services.
That's a great answer, because I myself did not think of Rust as the web service thing. But that's great that I was doing that. Okay, so Anthony asks, what are some things that are being worked on in the language right now? Who are some of the interesting people to follow? What are some interesting projects to follow?
Very cool. Yeah, there's a lot of things. So I think one of the last bastions of Rust development is error handling. Rust has, I always laugh at this because I came from JavaScript, but Rust has a small standard library compared to JavaScript. Any standard library seems huge. But we often let things experiment in the ecosystem for a really long time before they kind of get promoted into the language's standard library. And so Jane Lusby, who is the collaboration project director on the Rust Foundation, is spearheading the error handling working group. And that is, I think, something that's particularly exciting. There's continued development on async. which is coming out of the language. There's the number of, I feel like I'd have to list off 20 people who are doing just absolutely fantastic work in async. And so I won't name any particular one, but they've been doing a really fantastic job of publishing kind of their ideas and works in progress. And so that's a really great one to follow. And then I guess I'll pick an unofficial project, but something I think is very interesting. I had mentioned the embedded and IoT work that we're seeing happen in Rust. There is an effort to do kind of like a mission critical specification of Rust called Ferrocene. It's coming out of this team called Ferris Systems, which is led by Florian Gilcher. There's a bunch of cool folks there. I would keep an eye on that. That's like you want to fly in an airplane that's run by Rust style stuff.
All right, people are typing in questions. They're being thoughtful. What is the Rust team's philosophy of backward compatibility?
Yes. So this is another amazing developer experience, kind of innovation, I would say, that Rust has. So Rust has very strong backwards compatibility guarantees. And I think that's best expressed through the system we have called additions. So an addition is kind of like a major version of Rust, but when Rust 1.0, we said, there's never going to be a Rust 2.0. So what additions allow us to do is, for your Rust program, you have a manifest, your cargo.toml file, and you're able to list what addition you're using. And as a result, the compiler is able to understand what edition that is, and it's able to compile, say, a 2015 edition piece of code with a 2021 edition piece of code, and they're able to work together. So ultimately, what we're able to do is we're able to introduce breaking changes into the language in a backwards compatible way. So there are breaking changes. We'll add new keywords. We'll, change like some idioms, but none of that would ever require you to change your code, so long as you kept it on that edition. So that is what I think at least is a very strong guarantee. Additionally, there's just a lot of built-in safety, pun intended, to how Rust does its releases. We have a 3-stage release process. There's nightly, beta, and then stable. And so we release once every 3 weeks. Nightly gets promoted to beta, beta gets promoted to stable. And we actually run every release on every piece of Rust code we can find on GitHub and Crates.io to ensure backwards compatibility.
Wow.
And that's called Crater. You can look that project up and you can see it. Definitely one of the more expensive projects that we run, but I think it's really important. And it's a really, really cool project.
Yeah, there was a question about an LTS. Do you have an LTS release concept? I guess you kind of answered that.
We do not, but there definitely has been a lot of discussion, primarily from ecosystem authors on that. I think we have been able to avoid that concept, but I think its time is coming. I think in general, what the goal of the Rust project is to have people stay up to date on stable. And the reason we do that is by having extremely high backwards compatibility guarantees, and like the cost of upgrading to the next stable is functionally zero. And so once you have an LTS, you kind of have people kind of get stuck on different parts of the stairs. And I think our goal is to make sure that climbing those stairs continues to be seamless and easy. And that way people don't have to to like stay on one particular one. Now, as I said, I think that this is something that we're definitely going to need to readdress at some point. And library authors, I think, are feeling the pinch of this the most. But yeah, I guess the answer is no, but there's been an immense amount of conversation about it over the last couple of years. Honestly, since the beginning of Rust, honestly.
So somebody asked about any particular resources you'd recommend to someone who is just planning to get into Rust programming. And there people have mentioned a number of books, Rust programming language, and then hands-on Rust. Yeah, do you have any others that you can recommend?
Yeah, I mean, there's a ton of just fantastic resources, and every day I feel like something new comes out and it's super fantastic. One of the less well-known is a series of screencasts that Nico Matsakis did like a long time ago. They're called Into Rust. And I really love them for great high-level explanations of lifetimes, ownership, and borrowing from the person who conceived of the idea, Nico. So the Into Rust screencasts are really fantastic. There's also Rustlings. Rustlings is, if anybody here is familiar with stuff like Node School, or there was like Ruby cones and katas. Rustlings is kind of like, it's a CLI application that does kind of test-driven Rust introduction. So it's a bunch of little exercises that kind of introduces you to the syntax. I think it can be really fun. What else? Yeah, I mean, so the other thing I would say, this is not necessarily for folks who are getting into Rust, but one of the things we identified a couple of years ago was that we had this interesting bimodal distribution of Rust developers, where we had a lot of people coming in the door and kind of in the beginner range. And then we had a lot of people over in the like expert, like ridiculous, like I write the Rust that Rust writes like people. And there was kind of this like difficulty of crossing the chasm in the middle. It's like, what does an advanced beginner do? Like where I've finished the book, like what do I do next? And so we created this idea of domain working groups. And the idea was like, okay, I've done the book, I'm going to graduate and I want to learn more advanced Rust concepts by focusing on like a specific type of programming. And so those 4 domain working groups were async or web networking, embedded, the CLI working group, and then WebAssembly. And each one of those groups produced a book that kind of you could hop into next. Now that was in 2018, and it's wild to think that that was 4 years ago. Things like async and networking have obviously blossomed into like massive like parts of the ecosystem. I think similar with WebAssembly, but for those 4, you can still find those books and resources. And I would encourage you, after you do the book, to kind of come up with a personal project and kind of explore one of those domains, because they are domains in which Rust really shines.
Noah asks, do you program in Rust outside of core development? And what kind of stuff do you like to build with Rust?
Yeah, so I think one of the things, and I didn't touch on this at all, so the way Rust governance is set up is that the core team, I don't think I would necessarily call core developers. Rust has like what I like to call a uniquely distributed and delegated governance system, where the core team exists to kind of coordinate across all of the teams, but there's a compiler team, a language team, a crates.io team, a cargo team, an infrastructure team, and those teams largely work independently and have their own autonomy. And then the core team is able to kind of recognize cross-cutting issues and focus on like general direction. So I would want to caution necessarily calling myself a core developer. There's like 200 core developers, I would say, of Rust. We're able to build all of these like official tools and stuff because we have such a large team. But I mean, and I've participated in developing a lot of those tools. But yes, I do program Rust outside of my open source work, though a lot of my open source work is also open source work. I love building CLI tools. I think that's one of my favorite things. So I've done a lot of that, and also CLI tools in service of WebAssembly is one of my favorite things, just because WebAssembly is often chaining like 800 compilers together. So
Andreas asks, I think you said something about Rust complementing other languages as opposed to thinking about Rust as another language, as either or. Can you talk a little bit more about what you mean by that, by using Rust in conjunction with other languages? Did you have the Rust integration story in mind when you mentioned this?
yes, I'm not entirely sure. I can guess on what Rust integration story means, but I also could imagine like 800 other different ways Rust integration story can mean. So I apologize if I get it wrong. So FFI, or foreign function interface, is often just like a deeply complex and kind of horrible experience in like a lot of different languages. So I'm always hesitant to say that Rust has a great FFI story, but compared to many other languages, Rust really does. Its interop story is pretty fantastic. And so making Rust, I would say in general, plays very well with others. And also the fact that Rust, when you compile it, you're able to create like a standalone binary. Even if you wanted to do like inner process operability with other languages, like you're able to achieve that really well. I'm a huge fan of incrementalism, and a lot of people are like, should I rewrite it in Rust? I'm like, you shouldn't do a massive rewrite of anything. Like it's probably going to fail and you're never going to finish it. But shaving off little parts of things and doing those in Rust can work really well. And embedding Rust into other languages has been incredibly successful. I think there's C bindings, there's C++. Like when Rust was originally developed at Mozilla, like it was to complement C++ in the Mozilla browser. Like they didn't just rewrite the entire thing. They couldn't afford to do that.
Sure.
So yeah, it absolutely does play well with others.
I would add to the fact about learning Rust. I've always found learning languages or learning anything, pick a project that you just keep doing over and over again, where you know the domain extremely well. You don't have to learn the domain, you know, the structure, you know, kind of like, it doesn't have to be like a to-do list or anything like that. Some people do like the game of life, or you could even pick out what you're doing at work. Obviously not your whole like thing, but maybe like a little aspect that you're working on. But you know, if you have a database and you have all of the things, you kind of know all the things you need to make, where you have your data stored or not, you can just quickly rewrite it and then see the language, see how you are using language, what it's like to develop in the language. You really get to experience, kind of like minimize the setup and maximize that payoff. Although in Rust it seems like there's quite a bit of work up front, but you know, still you learn a lot.
Oh yeah, and I mean, one of the things I didn't include in this presentation, though I think you could see where I would plug it in a couple of times. Like one of the things that's really delightful about Rust, and this comes from its like systems origin, is that when you're writing it, it teaches you a lot about like complexities that other languages may hide from you. There's a joke inside Rust about whether or not you ship clone to production or not. But one of the biggest traps in Rust is like, it is incredibly performant, but it also gives you all the knobs to make your program super performant. It makes you aware of like all the copies that you're making. So, you know, you might write a JavaScript application and like be completely unaware that you're like taking this one like massive data structure and copying it like 400 times. Rust is going to let you know that you're doing that. But one of the things that's I think is just kind of sad is like once you know, then you're like, oh my gosh, I have to like fine tune all of this. How dare I copy anything? But Rust is very fast, and even with some clones or copies in a Rust program, it's often much faster than another language. But because Rust lets you know like all of those different things that you're doing, I think another example is just like the complexity of strings. Like Rust is gonna help you understand why strings are complex, like the things that other languages often hide. And in that way, it like teaches you a lot about how other languages work. And so even if you don't end up using Rust at your job, or you decide it's not the right fit, learning Rust can help you understand how other tools you're using work and what their trade-offs are. And I always find that like incredibly satisfying.
I bet a C or a C++ developer, which we probably do not have a lot of here, will have a completely reverse experience. They would be like, "Oh gosh, this is so nice, So I don't have to do all."
Well, it's interesting. I think some C and C++ developers really hate Rust, and then some of them really like it. Rust tends to be very polarizing, but yeah, I mean, I think that goes back to the like, and as I said, like I think there's an empathy for this idea that like if something is nice, like you almost don't trust it because you assume that it's an abstraction that's costing you in the long run.
All right. Well, thank you so much for speaking to us about Rust. Great session. We are going to have a lunch, and I will see everybody back here or wherever your next session is at 1:30 p.m. Thank you so much, Ashley, for talking to us about Rust. Have a nice day.
All right, thanks. Bye.